Hello, everyone. September 13th. Alright, let's see. We have been doing easy, I think, for 3 days straight. Today should be hard. I am mentally ready. But it shows up as a medium, which is alright. Let's see. Vowel spell checker. So for the past 3 days, it's been vowels and consonants for 3 days straight. And today is vowel checker. Given a word list, we want to implement a spell checker that converts a query word into a correct word. For a given query word, the spell checker handles 2 categories of spelling mistakes. Capitalization. If the query matches a word in the word list, case insensitive, then the query word is returned with the same case as the case in the word list. For example, if we have this and this, we will return this. If we have this and this, we'll return this. If we have this and this, doesn't really matter. Vowel errors. If after replacing the vowels of the query word with any vowel individually, it matches a word in the word list, case insensitive, then the query word is returned with the same case as the match in the word list. So if we have this, and we have YOLO, and I will make change to match. There's no match because we have 2. And there's also no match because the length doesn't match. In addition, the spell checker operates under the following precedence rule. When the query exactly matches a word in the word list, case sensitive, you should return the same word back. And when the query matches a word up to capitalization, you should return the first such match in the word list. When the query matches a word up to vowel errors, you should return the first such match in the word list. If the query has no matches in the word list, you should return the empty. Given some queries, return a list of answer where answer I is the correct for the query. So word list is this, query is this. Well, I'm gonna go through this, just kind of drill down again what the rules are. What interests me more is the size. So word lists are both 5,000, which I think, I'm not sure. Word length is only 7. So there is going to be some brute force involved. Now, I'm pretty sure the word list we have to do a try on this. It's to make matching easier. I don't see another way, because it requires you to return the first. So there's like a precedence. Okay, here's a question: can we have 2 exactly the same? Probably no. We probably cannot have 2 exactly the same. We're going to just try. Oh, holy crap. We can't have exactly the same. Kite. Okay, the things I want to try. So this kite is going to be returned this because this is a full match. But what if this match is like this? You should return the first one. Yeah, return the first one. Let's say we build a try. Okay, this is the root. And we have K, large K, small k, large, small h, large H. Oh, already split. I, T, E. Right, here is the same. Let's just write it down. All right. So when it comes in is kite. KIT. Now this is the thing. If you do it this way, I don't know which path to go down. I say we do both. But then how do you know? It says when the query matches up to calculation, return the first such match. So we should also put this as index. So this is 0, this is 1, this is 2, this is 3, right? So we start match. We actually match both. Actually, we will match every single one because you can replace with any vowel individually. So you just essentially match everything, right? Match everything as much as you can. And once you go through the entire word, at the end, you will have, because it's going to be a queue, right? Well, it's going to be a queue. So we just keep pushing the nodes in, right? We keep pushing the nodes in. And at the end, we'll have this coming out. We're just checking, right? We just check. But you also need to know it's a full match or not a full match. A full match or not a full match. Yeah, just it's a match, right? So at the end, we'll say is a full match. Is a full match. So we'll have a full match, call it F. We'll have a capitalization match, and we have a vowel match. We have 3. So you put it along as you're matching towards the end. Then you go through this. Maybe you should sort it. Maybe you should sort it. Yeah. Index. So full match will be 0. This will be 1. This will be 2. And it will be a pair, this with this. So you sort this first. If this is the same, we sort based on this. So everyone will go through this. The layer is only 7, so that shouldn't be too much. Everyone's only 26, so it's 26 times 7. That's not too much. That's like okay. I don't think it will matter that much. And if we have repeats, which is totally fine because I just like this exists will be this, and I'll just put it there. I don't even need to put this. This is not necessary. All I need is the index. That's it. All right. I think we have a strategy. We just need to implement the try. I don't think I will do anything smart regarding the implementation. I think I'm going to go and create something called a try node. Try node. What do I need a try node to have? Technically, these should be private, but it's fine for our purpose. I need a, holy crap, can I even define like that? Anyway, I need a map, an order map of char. That's gonna be a lowercase letters. Oh, the lowercase or uppercase? No, it's just a case. Doesn't matter. So I need a trie node as well. Actually, not sure. Is this gonna work? Mapping. I guess it's gonna work. And we're gonna do index. Can I define as default value though? Is this legal? I guess it's legal. Add the -1. I guess it's legal. All right. So the trie node is done. Let's see what we're gonna do here. This is what problem this 966. We will build a trie based on the word list. Then we will match each query to the trie. We define a full match as 0, capitalization match as 1, and vowel match as 2. I mean, vowel match essentially means if at this position it's not a match. Yeah, here is the hierarchy. Is it a full match? If it's not a full match, is it a capitalization match? If it's not a capitalization match, are the two letters both are vowels, right? So that's the 3 categories, and you assign them 0, 1, 2 basically. A vowel match as 2, right? And after each query, right, is matched. After each query is matched, we will know, right? We sort the result, the matching result, right? We sort the matching result first by match status, then by indices, right? By word list indices. And the one at the top is the answer, or something like that, right? Runtime would definitely need to go on. I think that's on. I think it's on. Well, technically on times 7, but I guess it's okay. Okay, so we're gonna do a trie. So trie node root. I have a root. And then we say for const auto w, const of word list. Okay. Trie node. What do I do here? Do we do a copy? Do we do a copy? I think we do a, no, we do a reference. Okay, we do a reference. See, this is the part I've never done before. Okay, so root is by itself, I created it, right? And then node currently is a reference to root. And then we're gonna go char c of word. Now it's gonna be interesting. Right, so if node dot mapping dot contains c, or if it does not contain c, then we need to create a new one. We say node dot mapping c is equal to trie node. Okay, so that I create a new one, and once I do that, That's it, right? That's it. And then we say node dot mapping C. This one points to the actual node, and no. We're gonna say node will equal to node dot mapping C. That's it. And this should not be a copy because this is a reference. So this will just be a reference, right? Node should just be a reference. No point in the next one. Okay, now we go on. Once we hit the end, the last one, okay, now we say node dot index will equal to, you did not do index, man. Can I do this? To just avoid a copy. And then blah 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 blah. This is fine. And then this will equal to I. Okay, so this is to build a try. Now the try is done. We need a result. Okay. So this will be result. And then we need to do the queries. So for each one, I need to start matching. I think I said I need probably a queue. Right? Probably a queue. Do you have a queue? Yes. This is interesting. This is going to be a pair. Okay. So now what? I don't have a node. Right, I have a node. Again, try node. So for so for each query, actually we need to put the queue. Actually, that's actually not right. It's not an int, unfortunately. No. I think this is going to be a try node. I'll put a reference. So it's a queued up push. This is a match status and the try node. We always say it's going to be a match. No, actually, there's no match initially. And then we're going to do the root. Okay. So for each one, we're in a while queue. We're just gonna pop everything, right? Or pop this every time we pop, we check, and then we push it back in, and push it back in. Okay. So int size equal to q.size, and then while size is large equal to 0, I'm going to say auto match status node. I'm not sure if this is the right syntax, but q.front, q.pop front. Oh, I just put a pop. Right, so I have match status, I have the node. And then I just need to check if node contains C. Right? Say if node.mapping contains C, then we're gonna do contains C, right? This is a full match. Full match, then we'll say q.push, we push back std maximum of match status a 0, and this node.mapping C. Right, this is a full match. Else if node.mapping dot contains, how do I do lowercase? To lower, to upper. Oh no, it's just to lower. So to lower, maybe it's std, to lower. Actually, I don't know. How do we call this? C type. Wait. We do need C type. Oh wait, hold on. There you go. So to lower C. Ooh. That's fine. We'll just do more. Capitalization match. Huh? I feel like it gotta be a to upper, right? Oh! What about to upper? It is to upper. C. Okay. Let's finish this one first. Alright, so now we have lower and upper. What about a you know what? So this would be a match. You know what? Let's keep this as a lowercase. So this is a vowel, but I don't match any of this. But it is a capitalization match on the vowels. I'm not sure if that one counts. It counts. It counts on the first one. Hold on. We're matching the first one. Why? Okay. I think it's just a capitalization. I think capitalization match is this. The next vowel matches, it doesn't really matter. Does not really matter. So essentially, else if C is a vowel, A-E-I-O-U. Okay, so now we just need to make sure this is a vowel. Now if is vowels C. Right, the current one is a vowel. Then we don't know if any of the mapping is a vowel. What if there are multiple? We put multiple in. So for const auto pair of not mapping, if is vowels p dot first, right? If it's a vowel, then we call this as a vowel matching. Vowel match. Q dot push. Status 2. Node dot actually p dot second. It's a match. Really? Okay, so val will match this. And if you don't match, you don't finish. If you do all these if else and you don't match, then just don't push it, right? And then once you're done, you go size minus minus. So blah blah blah. Once we're done, right? Then we come out. We'll check Q size, right? If Q has wait, hold a second. This we're still at. This is just the character. Now we go for the second character, and the third character, fourth character. So once we're done for this character, for everybody in this query, okay. So we say if q.empty, right? We didn't get anything. So that is when rest.pushback is empty string. Else we have something in Q. Can we sort Q? I think we can. Right, we'll sort. I need to put an index. In fact, I need to put a gigantic index. I need to put in the max. Int max. Vector. If we're in the filter, I think the -1 is fine. I'm gonna filter this. Eligible. Eligibles. Match status node of Q. I don't think we can do that. That's fine. While Q dot empty I think const is fine. Status node front pop if node dot index larger equal to 0. Eligible dot pushback match status and node dot index. Okay, once it's done, we're gonna sort eligibles dot begin, eligibles dot and then we'll say rest dot pushback eligibles 0 dot second is going to be the index, and we need to do What we need to do? Word list. And then we return less. Very, very long. You know what I think? Maybe it won't even compile. I think I got it wrong. This is what? For each query. Is it if and else? Is this for if and else? Rest I'll push back. And then we'll go for the next one. Here, return rest is here. All right. Can I reset? Actually, I like this one. Hold on, let me pause this one here. And I like this one. If I want to reset. We have some address issues. That's the thing, it didn't tell you where it got wrong. We didn't tell you. I mean, I'm not gonna go through this. So this is the thing. Maybe here I should do a pointer. That's the thing. Like I feel like maybe I should do a pointer here. But then you have to. Don't know. This I'm actually storing. This isn't. Alright, what's the best way to define a trie? Define a trie. What's the best way? Trie node. Ooh. Using a struct. Huh. That is true. We can use a struct. And we don't have to use map. We can use a array. Unique pointer. Okay. Let's do this. We'll now use a class. Screw you, this is 26. Try node. What do we do? This equals make unique try node. I think this one should be fine. Wait, if I try like that, and this shall be a unique pointer. So maybe I should do this as a pointer. Alright, I call it mapping, so let's still call it mapping. Oh no, I can't do it. I have to 128. C. Check for unique pointer, no unique pointer. Check for no unique. It's no pointer, okay, it's equal to, if it's equal to no pointer, then this will be make unique try node. Alright, so this will become a unique pointer. Oh, I think maybe root need to be a unique pointer as well. Unique pointer can only be moved. So this can only be a pointer to the unique pointer. So I can only do try node pointer dot get. Okay, so this part is good. Oh my god. So this is, again, I think it should be a pointer. Try node pointer. So I'll push root.get blah blah blah. This is yeah, I get these out. So node again. Mapping C not equal to no pointer. So it's a full match. So I push this and this dot get, else if this it's not equal to no pointer. Yeah, this gonna do here is also wrong. This is gonna be letter and node. Wait, hold on. This is right. P. Oh, it's not a mapping. Damn. Oh. So C is a vowel. So we're gonna go through all the vowels. Wait, hold a second. I need to go through, because I'm at this node, right? So we have node.mapping. So I need to go through every single one. It needs to be a not a null pointer, and okay, that's actually not right. 128. If node mapping I is not equal to a null pointer and is val I, right? If it's a vowel match, then we'll do no mapping I dot get. Oh, so blah blah blah. We have this, and we have this a node. This should be node index and push back node index. Okay, let's hope this one's right. I'm not sure. It's some C++ stuff. If this one's wrong again, I have to debug. Okay, so it's not wrong in terms of the code. I mean, it compiles, but we got issue with here. Interesting. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I have this. All capitalized letters. Expected is this, not this. Yeah, that is a full match, but moving on, I have this maximum stuff, right? So initially it's going to be a full match, but it's going to be part when I push it back in, it is going to have the std max, so it's going to be a capitalized match. So this is going to be a capitalized match, and then at the end I have the index. So my expectation is this shall come before this. I don't know why it's the other way. Anyway, I think at this point we have no other choice but to run the debugger. Yeah, it is getting a little bit more complicated. I'm pretty sure it's some silly mistake that is preventing you from getting it right. Oh shoot. Should be a word list. Actually, this is the only one I want to test. What is the spell checker? Compiles. Let's take a look at this thing. You follow this thing. Okay. First, second, H, Q size of the one, Q dot front. Alright, so we need to have a match status, but we don't have match status. And we all know what a node is. Node mapping. sees a capitalized H. Capitalized H is true. Oh, capitalized H is true. I already go on. Oh, shoot. I see where I go wrong. I see where I go wrong. I should, for every single one of them, it should always be like this. I need to go through every single one. Damn. Alright. That's alright. That's alright. We learn our lesson and then we will learn from it. So essentially what I do now, I have to go through every single one. Right? So basically it has to be not equal to this. And then here is the interesting thing. So if I is equal to C, right? This is a full match. I don't know. I actually need to copy and paste this thing. All right, so it's a full match. Else if else. I feel like we have to copy and paste this whole thing. So I is equal to C. So I equal to to lower C, or I is equal to upper C. Yeah, I think I know this. It should be I. So this one is going to be a capitalization match. Okay. And else if is vowels I and is vowels C as a vowel match. Right, we go through all of them, 128 of them. Technically, we don't have to go through 128, but I think I'm just a little bit lazy. We go through 128 of them, find the ones that are not null pointers, so we have something in there, and then we'll check what they are. Full match, capitalization match, vowel match, and then we update them. And then once we're done, we reduce the size. Actually, I think we should reduce the size here, just so that, you know, it makes more sense. And the rest, I think, should be the same. All right, let's give this another run. All right, try it. Ugh. I don't know what happened here. I don't know. How am I supposed to debug this thing? This is a pointer. So basically it's saying this pointer is pointing to, it already got dereferenced. I think that's what it's trying to say. It got dereferenced. Why would it be dereferenced? It tell me node is now empty. How is that possible? The premise is it's not an empty. I don't know, man. This. Oh no, that's not right. Oh yeah, it is. He's still calling me bad. I don't know. I have no clue. I have all these. I don't understand. I don't know. The pop has to happen afterwards? I think, oh, because you're taking I'm taking a reference. So I think these are reference to Q, the element. Therefore, I cannot pop it until afterwards. Because if you pop them, I think it goes out of scope. Right? It goes out of scope, then it's bad. So we pop it at the end. Alright. Some C++ stuff. Ugh. Darn. Holy crap. How many? Jeez. Alright, I think I only need one of them. I don't know which one. Alright, so all you guys can just go to sleep. I don't need you guys. I only want the last one. And for here, I don't even know. I don't know, if it's wrong, then we, oh, it's wrong, so we delete a bit more. It should be binary search, come on. You learn it. So binary search. Oh, we got more mismatch. Okay. This is serious. We got more mismatch. Almost there. I think I will delete another round. One, two, three, four, five, six, seven. Seven more. And a second one, I think will be 2 errors will be even better. Oh, I think I deleted it. Shoot. One, two, three, four, five, six. One, two, three, four, five, six. Good. We have 2 wrong cases. I can delete the rest. I don't need the rest. Okay, so now the question is, I have a gigantic thing here. So, ooh. So basically, my answer is HOU, and the expected answer is HEA. KEO and KOA, I think it's something to do with the vowels thing. So first is a full match, right? And then I have, so HEA shall happen before, hold on. All right, let's do this. Let's simply, I'm gonna copy this whole giant thing. Need to verify some stuff, all right? So, HOU. This is not helping at all. Comma. That is not helping at all. It didn't turn into a new line. Oh, I remember. I think it has to be R. There we go. HOU is 2449. Right? HOU is 2449. HEA 2928. 2449 is earlier. I don't understand. This one is earlier than this. Woo! What are the rules? KO 273 KOA 1999. I am not sure why. Yeah, I'm doing this like extreme events. This is essentially what we have. Okay. This is right. But why in the other way it's not right? How put KIO? I don't understand. Yeah, don't worry about this. Let's just keep. Okay, I think we delete too much. Again. Nice. Yeah, I don't even care about the second part. Oh, Jesus. Oh my goodness. I was going to say, I don't even care about the second part. But I'll leave it there. Again. Okay, now we have a different situation. Can we search for HOU? SHOU? HEA. HEA is much earlier. Interesting. I'll remove everybody after this. We're getting there. We're getting there. Huh. Something interesting. Something along the way is causing me issue. Wow, I have not done this type of debugging for a very long time, but we're getting there. Oh, it's correct now. So something in here is causing me issue. Yep. All right, I'll keep doing this, but I need to feed my cat. We're getting very close. I am curious. I am very curious why. Anyway, I'll be here for now. I'll see you guys tomorrow.